Hey everybody. So we're looking at 15.4 part 2 today, which still deals with the segment relationships and circles. But today we're going to look at a new theorem called the tangent-secant product theorem. All right, before we get into this really quick though, I want you guys to recall the secant-secant product theorem that we learned in the last lesson because today's is very similar to it. All right, so I'm gonna have you guys go ahead and try this out. Just a little reminder, when you guys go to set up this equation, the idea is that this outer segment times the entire secant line is equal to doing that with the other line. All right, so maybe to get you started here, the outer segment of this one is 7. The entire line is not x, it's x plus 7, right? Okay, so there's my first one, and I can set that equal to doing the same thing with this line. So go ahead and complete the equation and then solve for x. Okay, so moving on to my other line, again, I'm taking the outer segment, which is 6, and I am multiplying it times the entire secant line, which is an 8. It is 8 plus 6. All right, and if we just wanted to do that math in our head, we can say, okay, 14. Okay, and then from here, we're just kind of, solving. So let's go ahead and simplify this. We'll distribute the 7, multiply the 6 together times the 14. So let's start with this. 7 times x is 7x. 7 times 7 is 49. Over here, 6 times 14 gives me 84. All right, and from here, subtracting 49, dividing by 7. Okay, and actually, I kind of recognize this problem. I think we might have done this one before. Okay, but still, good practice. So 84 minus 49, we're getting 35, and 7 goes into 35 5 times. So it looks like x equals 5. Okay, and I always just double check, is that what they wanted? Yeah. Okay, so what we're doing on this theorem is very similar to what we're going to be doing today, but you'll see these problems kind of start simple and then eventually end up into fairly complicated problems. Okay, so yeah, go ahead and get this title here, and then I'll scroll down and show you the whole tangent-secant product theorem. Okay, so here is the whole theorem here. Go ahead and copy this, and I'll explain what's going on. Okay, so first thing, tangent. All right, a tangent line is a line that just touches a circle at a single point. All right, so this blue line here, since it's just touching the circle at one point here, means it's a tangent line. Okay, a secant line technically is a segment that touches a circle at 2 points. Okay, so that's just technically the difference between those two words. But when we go to do the formula, all right, the first thing we're going to do is square our tangent line. Okay, whatever it is, say it's 4, we're going to have 4 squared. Okay, with our secant line, we're doing the same thing we did on the warm-up. We're multiplying the outer segment, EC, times ED, the entire secant line. Okay, so that's our sort of new formula. It's very similar to the other one, but just, a little twist with this whole tangent line. Okay, so let's try out an example with this. Okay, so go ahead and copy this and we'll try it together. Okay, so find x. When we go to do these problems, normally what I'm going to do is I'm going to start by squaring the tangent line, just like our formula says right here. So let's go ahead and do that. Tangent line is 5, so I'm starting with 5 squared. Okay, setting that equal to doing the rule with the secant line, taking the outer segment 2 and multiplying it times the entire secant line, which is x plus 2. Okay, which by the way, you could do 2 plus x, but normally I start with a variable. Okay, and here it is. Now we just need to simplify and solve. So 5 squared is 25. Distribute the 2. Looks like we're getting a 2x plus 4. And now subtract 4 and divide by 2. Okay, so this was a fairly straightforward, quick problem. And when you go to do these, they often or sometimes will be this quick. Here's what I noticed: when I divide 21 by 2, I'm not getting a clean number. But that's okay. That potentially could happen. When we divide by 2, I'm going to get a 10.5. So I'm going to flip it around. X equals 10.5. Okay, so yeah, that is, an example of one of our problems. And you can see, wasn't too difficult, though like I said before, they're not always this simple. So let's try another one. Okay, go ahead and copy this one, and we'll see what happens. Okay, so on this one, what I notice is my tangent line, which is where I'm going to start again, is where my variable is. Okay, so again, we square our tangent line. So we're going to do x squared. Okay, on the other side, we're doing our rule with our secant line, the outer segment, which is 4, times the entire secant line, which is 6 plus 4. All right, in your notes, if you wanted to show yourself we're doing 6 plus 4 instead of just putting 10, that's fine. I don't mind, though, if you just jump straight to 10. Okay, but yeah, let's do both of these steps here. 6 plus 4 is 10. 4 times 10 is 40. Okay, so you can see on this problem, we're actually, needing to get rid of this power of 2 to solve for x. And this is something we haven't seen in a little while, but you guys probably remember to undo squaring, we have to do the opposite, which is square rooting. Okay, and that means we have to also do to the right side. Okay, so those cancel out. I'm left with x. Over on the right, I have the square root of 40. This is where you can grab your calculator and just go ahead and type it in. Okay, if you have trouble with the whole typing it in, let me know. Also, if you need to use the GeoGebra website, feel free to. Okay, but I'm getting 6.32. We're going to round these to 1 decimal place, the tenths, like we normally do. So I'm going to write this as 6.3. Okay, so that really wasn't too difficult, though our variable being in this spot, changed the way this problem ultimately unfolded. You'll see that where the variable lands really dictates how these problems are going to be done and how difficult they might turn out to be. Okay, so I'm gonna have you guys go ahead and try out 2 examples here. You can see one of the examples are variables on the tangent line. The other one, it's part of the secant line. So go ahead and try these 2 out, and then we'll look at one more type of problem after this. Okay, so on this first problem, we have our tangent line. Starting with that again, we're gonna square that tangent line, whatever it happens to be, and then setting it equal to taking my outer segment, 1, and multiplying it times my entire secant line, which is a 3 plus 1. Let's just do the math and say 4. All right, so go one more step. 1 times 4, it looks like we got 4. All right, and be careful. It'd be tempting maybe to stop here, but we have to get rid of the squared, which is undoing it with square rooting both sides. All right, and this turns out kind of nice. Most people, have memorized the square root of 4 is 2. And there it is. Okay, moving over to number 2 here. Again, starting with my tangent line, I'm going to square that. So 7 squared. Moving over to my secant line, the outer segment, 5 times the entire secant line, x plus 5. All right. So yeah, let's do a couple things. I'm going to distribute my 5 and I'm going to square my 7. So we got 49 equals 5x plus 25. And then subtract 25 and divide by 5. So let's see, 49 minus 25. Might as well use my calculator since it's here. I'm getting 24 equals 5x. Divide both sides by 5. I'm getting a 4.8. I'm going to flip it around. Okay, so yeah, that's how fast these problems can be done. They're really not too difficult, but just notice how differently they were done depending on where the variable lands. Here's the thing: we had our variable land on our tangent line. We've had our variable land on the inside of the circle. What if our variable landed in this spot, the outer portion of our secant line? Okay, we're gonna see what happens. Okay, so let's try one of these problems where that's happening. Go ahead and copy this. Okay, so for all we know, this is the same type of problem. So we're going to start it the same way we always would. Start with squaring our tangent line. So 16 squared. Okay, and that's equal to our outer segment x times the entire secant line, which is an x plus 8, right? All right, so taking a look at this, you might start to see why this is going to turn into a little bit more elaborate problem. When we go to distribute our x, okay, and by the way, we can square our 16 in the same run. So let's see, looks like we're getting 256 on the left On this one, x times x is x squared. X times 8 is a positive 8x. Okay, here's the issue. We now have a quadratic and also just x by itself. Okay, this cannot be solved using, just square rooting. I have essentially two different things I need to worry about, right? So this is a quadratic equation. So the question is what do we do? Okay, well, the first thing we want to do is we want to get everything to the same side of the equation. All right, by the way, this is something you probably haven't seen since, Algebra 1. All right, but let me show you what's going on. So I'm going to take this 256 and I'm going to bring it over to the same side as my other stuff. Okay, so it's gone. I have a 0 over here, over on the right. None of these are like terms. That's why I wrote this 256 over here. So I'm just going to write them one after another. X squared plus 8x minus 256. Okay, and now I have a quadratic equation. All right, and I need to use, there's actually a few methods to solving quadratic equations, but if you guys remember, probably the quickest and most foolproof is using the quadratic formula. All right, so there's something you probably haven't seen in a long while. It may be something you're a little intimidated by, but I want to show you how really simple the quadratic formula is. So take a minute, copy this, don't be intimidated, and we'll try it out. Okay, so first things first, quadratic formula. The nice thing about it is it's already solved for x. All of the solving and moving things and all of that has already been done for us. And all we have to do is plug in some numbers and type them into our calculator, basically, and we have our answer. That's really the nice thing about the quadratic formula. And all we have to do is make sure we get our numbers in the right spots. When we have our quadratic drawn out this way, okay, this number in the front is a, this number next to x is b, and the number by itself is c, okay, which, by the way, this is called standard form. All right, and then we just need to plug our numbers into the spots here and then do the math. Okay, so again, don't be too intimidated by this, but let's go ahead and try it out with ours. Okay, so ours is kind of flip-flop, by the way, 0 is on the left. We could put 0 over on the right like this. If that helps you, you can, but it really doesn't matter. But what I want to point out is what is our A, B, and C value? Okay, well, our A value is this invisible 1. So I'm going to go ahead and just point out A is 1. Our B value, which, let me see, I think I made it blue. Yeah, our B value is this number in front of X, which is a positive 8. And our C value is this number by itself, which is a negative 256. Okay, sometimes I like to list out A, B, and C. And again, I'm talking about this right here, just because now I can plug it into the quadratic formula pretty easily. Okay, so real quick on this, let's go ahead and write out the quadratic formula right underneath it, and then we'll plug some numbers in. So x equals negative b plus or minus the square root of b squared minus 4a times c all over 2 times a. Okay, take a second and get that here. Okay, so now let's plug in our numbers. Okay, x is what we're looking for, that stays the same. But looks like we're going to plug in negative b. So negative, our b value is an 8, plus or minus the square root of b squared, so 8 squared, minus 4. By the way, that minus 4 is part of the formula. It will always be a minus 4 right there. But times a, which is 1, times c, which is a negative 256, all divided by 2 times a, which again is 1. Okay, so there's our numbers plugged in. That really wasn't that difficult. Now we just need to start using our calculator to simplify this thing. This is where we just have to make sure we do it in the correct order. Okay, first thing I'm going to worry about inside is what's underneath my radical. I'm going to square my 8, and I'm going to multiply these 3 numbers together. That's what I'm going to do on my first step. Okay, so this other stuff I'm just bringing down, negative 8 plus or minus square root. Okay, 8 squared is 64. And negative 4 times 1 times negative 256 is giving me a positive 1,024. Okay, use your calculator, obviously. Down on the bottom, all divided by 2 times 1, 2. Okay, so let's keep going. We got negative 8 plus or minus. Now I'm just going to add these together. So 1,024 plus 64 gives me 1088 divided by 2. Okay, and depending on how you do these problems, some of these, if you were taking a multiple choice test, potentially, this would be your answer. As crazy as this looks, this is one way of writing the answer. If you're not asked to simplify, the radicals or write it as a decimal, this is actually your best looking answer. All right. I'm trying to think if we want to go one more step. I think we should go one more step and actually write this as some numbers. All right, so let's go one more step here. I think it'll just be one more step. Here's the thing. This plus or minus, there's two different values for x here. Let's write both things. We got x equals a -8 plus the square root of actually let's find the square root of 1088. I'm going to type that in my calculator. Square root 1088. I'm getting 32.984. I'm trying to think of how we want to round this. If we round too much, it might be inaccurate. I guess just to keep it simple, we'll round one decimal place. So 32.98 is going to round that 9 to a 10, which rounds this 32 to a 33. Okay, so we're kind of rounding here a bit, but there's one of our potential ones. Or our other one is -8 minus the square root of 188, which again is 33 divided by 2. Okay, so now let's do the official last step. Let's do this math here. So 33 minus 8 is 25. 25 divided by 2 is 12.5. And then our other answer, or -8 minus 33 is -41. -41 divided by 2 is -20.5. Okay, and those are our two answers. Okay, so that was nuts, right? I wanted you guys to see this because it's a possible type of problem that you can get here. Okay, but just know this only happens when your variable is on the outside of your secant line, okay, which will potentially happen. It won't happen a lot because these problems are so long, but it is a possibility. Okay, cool. So I think I'm going to leave it at that one and not torture you and have you try one on your own. But if you'd like to, here's the problem I was going to give you. I'm going to end the lesson here. But if you want to try one on your own, give it a try and I'll put what the answer is. All right, guys, I'll see you.